Now that we've created a project for our multidimensional analysis services cube, we're going to talk about the needed entities for developing the cube. The first one is creating a data source. This is a connection string, and in most cases is to a relational database that contains a dimensional model. The dimension and fact tables exist in this database in more of a cleansed data area. The data source can be SQL Server or any relational database that a provider is available for, like Oracle, DB2, or Sybase. In this example, we'll be using the AdventureWorks 2014 Data Warehouse. Also, your data source can be a connection to a text file, flat or comma-separated variable. So, why is it important to have a data source? Well, a data source is needed to create a data source view. The data source view is the source for dimension and cube objects. This connection string provider usually gives you a driver, server, or instance name and also displays relationships between the columns of the dimension and cube objects. All of this is in the connection string once you build a data source. It also has security connection like the login information. This is all used to retrieve data from the cube. Additional options are based on the provider that you're going to use. For SQL Server, this is a client provider, and these can include the query timeout and also information about integrated security. The connection string properties can be changed if resources are being hogged by analysis services. This connection and the processing of data can affect performance, and if you change some of these properties on the provider, it can relieve the resources, which will make your DBAs happy. Now, let's go create a data source in our existing project. Okay, let's open SQL Server Data Tools and find the previously created project. Go to Start, SQL Server Data Tools, and open it for Visual Studio 2013. Once the environment is opened up, we can go to the File menu choice to Recent Projects and Solution and find the last project we were working on. Once that's opened up, we can see the folders available in our Solution Explorer. We're going to right-click Data Sources and create a new data source. On the Welcome screen, we'll click Next. In the list of data connections, we're going to need to create a new connection to our data source. In the bottom right, click the New button, and here we will give it a server name, and we'll just place a period for localhost, or type localhost, or type the server name. Once that's in there, you have available to select the database to use. Under Connect to a Database, we'll click the drop down and we'll see the AdventureWorks DW 2014 database. We also have the option here of changing it from Windows Authentication to SQL Server Authentication. We're going to stick with the Windows Authentication and click on the All button to the left. Here are the additional properties available for the provider that we're connecting to. In the upper part of this Connection Manager window, you can roll down the list of available providers. We're not going to change this, so we're going to click Cancel and then click OK. Now that we have that data connection created, we'll make sure it's highlighted in our data connections and click Next. Here, we're going to talk about security. This is the impersonation information. You can actually enter a Windows username or password, but sometimes that's not available because passwords change over time. The best option is to choose Use Service Account. This account, it should be an Active Directory account that can process a cube and connect, read at least, the tables in the data connection. Usually, you work with a system administrator to have a SQL Server and analysis services Active Directory accounts set up for these services. SQL Server permissions can be managed in the SQL Server Management Studio and Connection Manager once created in AD, and the proper login as service has been assigned along with other file management permissions. We'll click Use Service Account and click Next. Finally, we're prompted for a name. We'll use the default and click Finish. Once that's finished, we see that the AdventureWorks DW 2014 data source has been created. If we right-click on it and go to Properties, all we really see are some general properties for that object. If we need to edit the object, what you actually have to do is double-click it or right-click and go to Open. This is where you're able to review those things we set up in the wizard. The impersonation information is on a separate tab, and we talked about using the service account. Under the General tab, you can actually see the connection string that was created and the data source name. Here we can edit this information and change any of the properties associated with it. We can also test the connection to make sure that the login information is working. We'll click OK and OK, and the final thing we're going to look at is towards the bottom. Here's where we look at the isolation level, query timeout, and maximum number of connections. Here's information you can control on the connection string if resources are a problem on this server. We can change the isolation level to snapshot, which will use snapshot isolation when connecting. We can tell the query timeout a lower number other than the default, which is 0, which is unlimited, so we don't sit forever with a query running on the server. The number of connections can be controlled because we can actually parallel process while deploying the cube. If too many connections are being made to the server, you can reduce this number. We're going to let everything default for now and click OK, and that's all we're going to look at as far as data sources is concerned. So let's talk about building a data source view from the data source previously created. What is a data source view? Well, a data source view is required to create a dimension or a cube. This object is used for the visual reference of the dimension and fact tables. It's also an area where relationships are created to join dimension and fact tables together. So why is this important? Again, it's required to create a dimension or cube. The fact and dimension tables located in this view contain the columns available for attributes of a dimension or the measures for a cube. Relationships built in the data source view enable the cube to connect to a dimension or measure in order to slice and dice by dimension attributes or hierarchies. Foreign keys in your table are very helpful. Also, the tables are abstracted in the view. This helps performance for processing a cube. Developers are given a limited list of tables or views from the data source database. This helps scale down the amount of columns and tables viewed from any data source, which is a typical thing used for performance gains. We're also using a data source view to view the data. Once you join to the dimension and fact tables, there's actually an Explore Data menu choice which helps you review the data inside of those tables. You might find out that you're connecting to the wrong table or viewing the wrong columns for your cube. Viewing the data is a great place to check this. There are additional options available in the data source view. One of them is calculated columns. These can be created in the data source view, like concatenating last name and first name of a customer dimension in order to have a customer column in that dimension table. You can also use case statements to define a descriptive name for a code column. For instance, the gender column in the database might be M or F in the database, but the user wants descriptive values, male and female, for the dimension. These changes work best in the database table and should be added in the dimensional model with the ETL code, but sometimes that is not available to you. The last thing we'll look at is a table can be replaced or created from a named query. The developer can change the table to be a select statement that limits the columns from a table. Performance gains can be made and improved by only selecting the columns needed for the cube. Let's go ahead and create a data source view from our data source in the AdventureWorks data warehouse. All right, with our previous solution and project open, we're going to look at a data source view object. We'll spend some time discussing the different objects available here. Let's create a new data source view. First, we'll right-click the data source view folder and select New Data Source View from the sub-menu. On the welcome screen, we're going to click Next. Now it's going to give us a list of the relational database data sources created previously. In our case, the AdventureWorks DW 2014 is the only one available, so we'll click Next. If there wasn't one available, there is actually a New Data Source button to step through the wizard to create a data source. Let's click Next. Now I'm going to widen this window so we can get a better view of the select tables in view. This is the main part of creating a data source view. In our case, we're just going to work with fact internet sales. So we'll scroll down in the list. You'll see the first tables have dim for dimension, and eventually you get to the fact tables. Here's our fact internet sales. We'll click it and click the right arrow to move it to the include objects. We can also just double click on either side to add or remove those tables. The next thing we're going to look at is there's a button in the lower right that says Add Related Tables. If we click that button, through foreign keys, the fact internet sales will show the dimensions with foreign keys. Here we get a list of the dim objects that we need in our data source view. Just to make this a little more manageable, we're going to remove currency, fact internet sales reason, and promotion. This will help us scale down what we're creating in this first look at data source views. If you notice, the product dimension is in the included objects, but on the left we still have product category and product subcategory in the available list. Since those aren't directly related to fact internet sales, they didn't get moved. So we're going to double click subcategory and category to move those in more of a snowflake schema for our data source view. Now we'll click Next, and it'll prompt us for a name. We'll keep the current name by default and click Finish. Here now we have a data source view of the dimension and fact tables concerned with internet sales. I'm going to go ahead and auto hide the Solution Explorer as well as the properties so we can get a better view. I'm also going to scroll to the left and move the subcategory under the product as well as category. This will help us be able to view everything together. I'll also go ahead and zoom to fit so we can get a better idea of what we're looking at. The first thing we're going to look at is using a named query to replace the table. If I go to the dim product category in the lower left and right click, I can tell it to replace table with named query. Here it creates a select statement with all the columns available from the table. We don't need all the columns for this dimension table, so we could either in the selection area uncheck alternate key, Spanish, and French name, or we can actually go to the T-SQL statement itself and actually highlight and delete that information from our select statement. Now, in order to make sure we're properly formatted the T-SQL, there's a Run button. If we run that and we get back the data that we're looking for, we're OK. We'll click the OK button, and now you'll see there are less columns available in this dimension. If you want to improve performance in your analysis services database, this is one thing you should look at. The next thing you should look at is actually creating views in the relational database and just adding connections to the view. You can do this by right-clicking in a blank area and creating a new name query. In this new name query, you can right-click in the workspace, click Add Table, and you can actually see the views in the table. We can actually go down to one that starts with V, and that's usually a view in the actual database, and add it here. And then close this window and check the columns that we want. Creating views at the database level will enable your DBA or administrator to help control the performance of some of these views. We'll click Cancel because we don't want this view in our data source view. We can do the same thing for the product subcategory table. Replace with a new name query, uncheck the foreign key columns, also uncheck the alternate key, but what we want to make sure is that we keep the category key, which creates the relationship between subcategory and category. When we click OK, we'll see that scaled down list. This is a very good practice to learn. Next, we're going to demonstrate how to create a calculated column. We're going to go over to the DIM customer table, right-click on it, and create a new named calculation. This new named calculation will be customer name. We can give it a descriptive name, and then we can actually build the expression. Here, we're going to grab last name, concatenate with a comma, and first name. Once we create this new named calculation, we'll click OK, and now we'll see how we can explore the data. If we right-click on DIM Customer and click Explore Data, it'll return back all the columns in that table, plus at the very end of this list, we'll see our new calculated column, Customer Name. Here, you can also explore the data to find out what columns you don't need in the customer database and then remove them through a named query. We'll close the exploring of the dimension for customer and go back to our data source view. The next option is to give friendly names to these dimensions. So rather than seeing DIM product, we're going to go to the properties and change it to just product. And now we have a friendly name as well as a name for the table. We'll do that for the product subcategory, and I'll pin the properties over to make it easily accessible. We'll do it for product category. We'll scroll to the right and get it for date. As well as customer. We'll finish the dimensions with sales territory. And finally, we'll get FAC Internet Sales, and we'll change that to just Internet Sales. Now we have a list of friendly names for each one of these tables, which will make it more viewable inside of the cube. Let's go ahead and look at Internet Sales. We'll right-click on Internet Sales and explore data. We'll hide the Properties window, and you'll see the surrogate keys for all the dimension tables in the beginning of this table. A little bit further, you'll see Sales Order Number and the Line Number, which are our primary keys, and then you'll start seeing the measures. Order Quantity, Product Cost, and then also Sales Amount. You also see the degenerate dimension columns, Carrier Tracking Number, and Customer PO Number, as well as the actual dates instead of the surrogate keys for order, due, and ship date. We'll close that and open up the DIM for product. When we right-click on product and go to Explore Data, we're going to see something unusual inside of the product dimension. Here we see that the product subcategory key is blank. It might cause us to look cautiously at this and say, oh, they missed the subcategory key in the product table. But that's not the case. If you scroll down in the list of available data, eventually you'll see the product subcategory key become visible. The first couple of rows that have products are not related to a subcategory, and their data is null. Usually ETL processes can handle this by providing a null or not available subcategory. This will be used when we start looking at the unknown member in a dimension table, so please remember about the null being in subcategory key. The last thing we're going to look at in the data source viewer are the relationships. If I double-click the relationship between internet sales and product, I will see the foreign key side and the primary key side. Now, what we're going to do is we're going to delete the existing relationships. The relationship between product and subcategory was added because there was a foreign key available when we imported this from the data source. I'm going to delete this to show you that if you don't have a relationship when you pull these tables in, it can easily be created. You remember, product has the product subcategory key. So if we click and hold on product subcategory key, drag it to the product subcategory key, and drop it, it'll create that relationship for us. Now, the reason I deleted on category is let's drag it from category to subcategory and see what happens. Here it says the relationship is currently between a primary key column and a non-primary key column. If this is incorrect, click reverse. So if we go in the wrong direction of the relationship, it'll actually let us reverse the order that we dragged and dropped the columns. Once we do that, we have no error message and we can click OK. Now we'll save our data source view, and now it is fully ready for us to start creating a dimension and/or a cube.